Thank you for coming. I want to talk a little bit today about the quantitative habit of mind. One of the things that I think in our discipline, or really in any discipline, that faculty wants is they don't just want their students to be in possession of a set of skills. They also want for those students to value those skills enough to activate them, even when we're not standing over their shoulders and telling them to do so. All of the mathematical and quantitative skills in the world are not useful to our students if they don't actually choose to engage with them in their lives. That's my contention, right? That ultimately what I would like as a calculus professor, for example, is I want the students to be able to carry out an integral, but I also want them to know when an integral is relevant and appropriate to a given situation, that they would choose to see that there is a question here that could be answered or addressed with that particular idea, and then subsequently to be able to do it. So what I want to do is talk a little bit about what habit of mind looks like within a quantitative literacy context. And then more specifically, how could we measure such a thing? That's always the tricky bit. How do we know whether or not our students are in a quantitative habit of mind? And then to the extent that we have some preliminary results, what do we know about our own students here at our institution as far as are they in the habit of mind to engage with quantitative and numerical content within the coursework that they see, within the world around them, and so on. So what is it, how do we measure it, and what do we know about how our own students are in possession of this quantitative habit of mind? So here's where I put you to work a little bit. So I'm going to hand out a reprint of a news article. Unfortunately, it's a little bit old. It's from 2008, so it's three presidential elections ago, believe it or not. It's from the USA Today. And it's a fairly short article, and I'm not going to tell you what the article says, because that's going to be your job. So what I'd like for you to do is to just read through this article on your own, and I have a couple of short prompts for you to briefly respond to. Don't feel like you need to write a lot in those spaces. Just get your reaction to those prompts down. We're going to take maybe 15 minutes or so for you to read this and respond to it. So let me hand it out. So the 5 questions that I asked you to respond to here about this article are, first of all, did you understand what the article was saying? And second, what was the main point of the article? Third, what facts did the author use to support the main point of this article? The fourth is, were there any particular strengths or weaknesses in how the facts were reported in this article? And finally, did the graph that you had on the last page help you to interpret the numerical information that was found in the text? Explain your thoughts. So this is not maybe typical of the kind of problem exercise that you would give to students in a math course. Is that fair to say? So let me bounce this off you. What is it about this exercise that makes it not traditionally mathematical?
I had to read.
All right, so the first thing you observe is that there was a lot of reading. Now, reading is, we have to read to do a math problem, but usually it's a couple of sentences, right? So there's a lot of reading here. Okay, what else? So what makes this different than traditionally? Is it something that you wouldn't normally see in a math class?
Correct answer.
Okay, so wasn't one correct answer. Okay, what else?
Not just answering problems, not just computing.
Okay, so it's not just problem solving.
What's problem solving in a literal way, I guess.
Right, it's problem solving plus, in a way.
Yeah.
Steve?
The question number 5 is so trivial to be in anything.
So you thought question 5 about does the graph help you to interpret the numerical information? You thought that was a trivial question. Okay, Steve?
It was a bit open-ended in a way that was, I guess, helpful, but also a little, I wasn't sure if I understood the article or not.
Okay. Okay.
That's what I
Or
said.
if I knew the article, I mean, I could guess at the main point of the article. But I feel like that opens up a lot of conversations about, is the thing that the author says is the main point of their article actually the main point of their article?
Sure.
And then I was like, well, I don't really know if that's the question that's being asked. And so that was why I didn't do very much for a while. So.
Well, in a way, so Tim mentioned there wasn't one correct answer. Maybe there's not a correct answer to that quandary either. Like, which main point did we intend for you to answer? I don't know that there's a right answer to that. I'm sure since they got paid by USA Today to write this, there must have been some intentionality behind it. Laura?
We're not really used to thinking in terms of evidence.
Okay. What are we used to thinking in terms of? If it's not evidence that we think about, what would you say we usually think about in math, if not evidence?
Problem solving, conventions of mathematical rigor.
Conventions of mathematical rigor. Maybe I can use the L word, logic. That there's somehow the logical reasoning that we use in mathematics classrooms, it's a higher burden of proof, pun possibly intended, right, than the sort of evidence-based reasoning that's happening in this kind of thinking sets. Anything else you want to add to this list?
I thought the article was relatively poorly written, that unlike a question, even a word problem in a mathematical setting, the information is clearly laid out, and so that was not the case here. You
Okay.
were constantly wondering, where does this information come from,
Yeah.
compared to what's missing here, and so it wasn't well laid out as opposed to a mathematics question.
Yes, absolutely. There is something very satisfying for both instructors and students when you do a word problem in a math class, right? That the right information to solve the problem is there. It's usually, hopefully, the author of the book has clearly laid it out for us, and we know that that's what we need. Whereas in a news article like this one, there is information scattered all over the place, and so it's not clear how to work with that.
Yeah, what you're raising there makes me think about when I started noticing that maybe the reason I don't understand the main point of this technical article that I'm trying to read.
So we're touching on a lot of the issues that one would have in extracting a story out of the numbers and the data and the graphs that appear in this news article from USA Today, right? So this, to me, kind of gets at the distinction between what quantitative literacy requires a student to do compared to what traditional math classes kind of require a student to do. Going down to a really sort of stripped down example. This is an example from a quantitative literacy assessment instrument sample exam. Say I give you these two charts, and I'm not going to ask you to do this calculation, but here's a chart showing what the cost of administering the 2010 US Census was for a variety of different categories in which the census investigates, or a variety of different categories that are related to administering the census. And the question is, how much money was spent on research in the 2010 census? So what would we have to do? Let's talk through this example together with all of this information on the screen to get us the dollar figure for how much money was spent on research in the 2010 census.
Right, so you have to figure out that research on the right from the pie chart is 19% of the costs, and then you'd have to go over to the other side and see what the total cost was to figure out what.
Okay, where does the total cost live in this diagram over here?
It's 19% of the other.
Yeah, it's 19% of the other costs. And where are the other costs in the diagram? Yeah, it's just this one bar down here at the bottom. So we have to navigate a lot of different pieces in this chart to even understand how to put, how to find the information that we need. Then what do we have to do with that information? We have a calculation to make, right? The total amount of money spent on research is, I'm going to be kind of pseudo-algebraic over here. Right, so not actually, it's 14,000 million, right? That seems like a lot of money. Well, I guess the census is it's a big thing. So it's $14,000 million multiplied by.
Okay, where'd you get that? I'm sorry,
Where did I get that?
560. That's the total cost, isn't it?
Yeah.
Research only 30% of it.
And research is 30% of that. Or sorry, not research. The other costs are 30% of that, right? So if I do 0.3 times that, now that's going to give me my total other costs. And then, so then I need to take 19% of that. And then that's going to give me my amount for just the research portion of this. I also had to, on the fly, I did a couple of things, right? I had to take this number, 14,526 million, and convert it into an actual decimal expression of that unit, right? I also had to take these percentages, 19%, 30%. I had to convert them into decimals. right? I had to also extract each of those types of information from a different kind of graph, a different kind of a visual, right? So there are all these steps. And then, if that's not bad enough, I also had to know what arithmetic to do with all of these figures. When I try to work these kinds of problems with students, I will see them try all kinds of weird kinds of arithmetic to do this, right? Oh, I just need to add the 30% to the 19% and then divide it by 14, by 26, right? So there's a lot of chances to make incorrect choices along the way. And so this is the kind of question where, this is actually a multiple choice question on the quantitative literacy and reasoning assessment. And so they give 5 different possible answers, one of which is correct. But what are we really assessing here? We're not assessing, I think, what we would call high-level mathematical reasoning skills. The actual mathematical computations that go into this are arithmetic. But it's the skill of extracting this information from these 2 different visual modes, and then understanding how percentages work and proportions work. Those are the key skills that one needs in order to carry out this type of computation. And that, I would say, combined with the fact that it's plugged into a context, that all along the way we're thinking about dollar figures and census costs, right? That the context in this problem is essential, in a way, is what makes this quantitative literacy more than just mathematics. What is seen in the literature as the distinctions between mathematical reasoning and quantitative reasoning. So I like to think of mathematical reasoning as a way to utilize basic math skills. And basic is a word you can define however you like. Math is also a word you can define however you like, but it usually incorporates arithmetic, algebraic, and statistical reasoning in some combination. So the math skills themselves are fairly straightforward, but the reasoning and decision-making processes that follow from them can be more complex. And they require the assessment of what is the right information that we need to answer this question, because it's not laid out and packaged like they are in mathematical word problems. And making choices about what decision-making processes or what algorithms or what statistical measurements are most appropriate for a given context. Quantitative reasoning tends to be more deductive. In other words, taking an idea and applying it to a specific situation. Whereas in mathematics, mathematicians like myself tend to prize the abstraction of mathematical ideas, right? We want to get to the essence of why does this percentage thing really work the way that it does, as opposed to how do we use this percentage thing to answer an application question. Right? And so in that way, mathematics is transcendent of context. We don't need to bring in any word problems or applications into a mathematics class to make it mathematical reasoning. But quantitative reasoning context is essential. It depends upon the context. So we can't learn QR, quantitative reasoning, without using it in a wide variety of different applications. QR, by virtue of its name, is almost always driven by data and numbers. These take the center stage. But mathematical reasoning doesn't have to be numerical in nature. There's a lot of math that is not numbers. Quantitative reasoning problems are very often ill-defined and equivocal. This gets to that idea that I give you this newspaper article and it has a bunch of data scattered all over the place and not organized in any particularly helpful fashion. And so we as readers have to hunt through it and figure out what is this question really asking and what information is really relevant out of this. Right? So that's ill-defined. It's very rhetorical. It lives in these gray areas where mathematics, because of the logical nature of the subject, tends to live in more black and white terms. This is a bit of a false dichotomy, but mathematics tends to be a central methodology in the STEM disciplines. You can't do a lot of physical science without mathematical reasoning per se. Whereas in the social sciences, a lot of the energy behind quantitative reasoning in higher education has come from social science departments because of the primacy of data and data analysis in those fields in quantitative work. That a student doesn't have a strong grasp of mathematics, for example, has strong implications to educational attainment and access. This was a topic that I think Ward forwarded to the listserv a while back, that students with unequal access to mathematics in their high schools face these barriers toward their educational attainment later in life that are socioeconomic, right? So there's a real danger in not having strong mathematical reasoning coming out of high school, because it really does limit access to later educational opportunities. Quantitative reasoning has these sort of consumer and civic implications. Being able to read the newspaper no matter how poorly written, or being able to listen to a presidential debate no matter how poorly articulated, right? And understand how the numbers and the statistics that are being used to support arguments may or may not actually support the arguments that they claim they support. That's a civic skill. Absolutely. The ability to mislead. You can mislead somebody in quantitative reasoning. You can't really mislead somebody, at least in sort of, let's say, elementary mathematical reasoning. There's not much opportunity to mislead. You can mislead with a graph, maybe. In fact, I would say that misleading students with a graph is a key thing that every calculus instructor needs to be able to do to teach calculus. There's actually a secret gap in that graph that I didn't show you. But for the most part, because of the gray that exists in quantitative reasoning, there's a much greater potential to mislead in quantitative reasoning. The K-12 standards haven't, as yet at least, called out quantitative reasoning as a specific standard. It's not something that's done. The Common Core state standards have begun to put more emphasis on standards of mathematical practice, so how students do mathematical reasoning and the attitudes that they have toward it and their ability to persist through challenge and that kind of thing. But quantitative reasoning per se has not really entered into the K-12 lexicon in the curriculum just yet. And I think another reflection of that is that the SAT exam still has a mathematics subtest that we still use in most places for admissions, although that's beginning to be relaxed in some places. Whereas quantitative reasoning is now how the GRE has branded its quantitative component of its grad school entrance exam, not the subject specific, but the general GRE that everyone takes. And I think that maybe in part driven by that difference, we're seeing more and more, as if you've listened to our core steering committee present on this in the recent history, more and more higher ed institutions are seeing quantitative reasoning as the standard that they want in their general education. In some places, supplementing mathematical reasoning, which I think is appropriate, and in some cases, supplanting mathematical reasoning, which I think is a slippery slope. To the extent that this is a false dichotomy, I believe that neither of these is really a complete picture without the other. That without a base of mathematical reasoning, one cannot be quantitatively literate because he won't be able to carry out the calculations and be able to understand sort of which abstract structure connects with a given situation. On the other hand, mathematics without quantitative reasoning leads to this common student complaint of when am I ever going to use this in my life, right? So what I think is best for our students is that they get both of those sides, right? And I'm hoping that's the direction that we end up going. The AAC&U, about 5 or 6 years ago, rubrics for assessing quantitative reasoning have a language that says, how well can a student take information and convert it to math? And then how well can they convert it back from math? So how well can they decontextualize it to discover the underlying mathematical structure? And then how well can they recontextualize the answer that they get to say, what does this answer actually mean? And so I would say that the process of decontextualizing the quantitative information in a problem is something that we might consider this inductive mathematical reasoning. What mathematical structure do I need? What tool is appropriate for the information given to me in this word problem? But then after the calculations are done and you have an answer, you need to understand what's the import of that answer. What does that answer actually tell us? Now we're doing quantitative reasoning again. Maybe we make a decision based on that answer. Or maybe we make some other recommendation or include it in some other type of reasoning. So it's not that we want students even to be doing one or the other of these in any particular case. We want them to be doing both. Fleshing out the AAC&U's definition a little bit more, they see quantitative literacy as having these 6 different dimensions to it. The calculational, which is can you actually sort of crunch the numbers, and we might think of that as being what students think of as mathematical computation. But then the rest of these are representation. How can we convert information into and out of different forms? So from a data table, for example, if we're using data into a graph, into a formula, into a written exposition, interpretation of results, how well do we communicate them, application and analysis, and then assumption. This is the critical reasoning part of it, right? What assumptions have we made that lead us to be able to apply a certain mathematical model? So there's a lot of different things that go into it. But going back to their definition one more time, the very first thing that they say, and the title of the talk, is that quantitative reasoning is supposed to be a habit of mind, right? Regardless of what these skills are, we also want students to be in the habit of actually using these skills. Not just when we're standing over their shoulders and telling them, tell me what this graph means, but when they're sitting at home in their bathrobe with their newspaper, reading USA Today on November 6th of 2008, after the election, opening the paper, seeing this article, and saying, highest voter turnout since what? Wait, let me look at that graph again, right? So those are the moments when we want students to be able to activate these skills in a self-directed kind of way. The problem is that habit of mind is really hard to measure. How do we know what students are going to do when they're left to their own devices? Anything we do to them on campus, and I use that direct object very specifically here, anything we do to them on campus to try to assess their skills is just that. It's something we do to them. If we give them an assessment of their quantitative skills and tell them, here's an assessment of their quantitative skills, then immediately that kind of poisons the well. right? We're no longer measuring their habit of mind, we're measuring their success in this skill set. Right? So we can't measure their habits unless somehow we get respondents that are unaware of the expectation that they will, on the one hand, value quantitative reasoning, right? That they believe that this is useful, that they'll choose to reason quantitatively rather than to reason in other less productive ways, right? To sort of look at this article and say, oh, I don't agree with this article, and toss it, right? So make some non-quantitative kind of judgment. We also want students to have the inclination, the tendency toward employing this pattern. There's the habit part coming in, right? That once you begin to see things with a quantitative lens, it becomes easier to see more things with a quantitative lens. And the sensitivity, right, to know when these skills are actually appropriate for the situation. These are the things that are really hard to measure in a state of nature, whereas capability, having the basic skills and capacity, and commitment, striving to improve your performance, these are things that, they're a little bit easier to deal with. But these first three, to me, really get to the hard things to measure when it comes to habits of mind. So now is when I'd like for you to take that response paper that you got from the person next to you, and to take a moment and just look at, I'm not going to have you look at problems 1 or 2, questions 1 or 2, where it asks, did you understand the article, what was the main point of the article? But take a look first at question number 3, and what the person wrote in problem number 3, which was, what facts did the author use to support the main point? If we read what the respondent wrote there, it should give us a measurement of whether or not the writer, that's you, sought out quantitative information from this article that was relevant and that was specific. So on the one hand, you might have had no quantitative information in there at all, in which case, I would just write a little 0 in the margin on problem 3. On the other hand, maybe there was some information, but it wasn't very specific, so you couldn't even tell whether it was correct or not. Say, oh, the article showed the trend in voter turnout. Maybe there was some correct information identified that was quantitative, but maybe it didn't tell the whole story. 62.5% voted this year. Or maybe there was a full and sort of complete assessment of the quantitative information that was in the page, in which case, 3 points. So try this for just a minute. Read what your respondent has wrote in question number 3 and decide how many points, 0 through 3, that you would award to that response. How'd you do? What kinds of scores did you come up with on this? 3s? So you were all able to identify what was the most relevant quantitative information and why, sort of identify what was relevant specifically in the quantitative information from this article?
But I look at that, when you say some, not all implies that we know an exact number of answers we should have had in here. An answer key, so that we could look at it, they were looking for 5 specific points.
Well,
and they got them
all relevant, right?
But one fact that the person made out of that was supported by what they wrote there. So I would call that a 3.
Mm-hmm.
It didn't have to be 4 or 5 facts there. When they looked at the main point of this article, did their answer support it?
Mm-hmm.
I mean, the rubric is very vague.
Yes, that's right.
Scoring rubric.
And so in this study that this rubric came from, they mentioned in their discussion section, like, yeah, we had some issues with the rubric. I feel like every assessment study ever published always has, well, we had some issues understanding the rubric. But this was the part of this assignment where they sort of most thought that they were getting at a student's habit of mind. If the student actually ran towards the numbers and the data to help explain this, and if they identified specifically how those numbers and data worked out, then they were engaging, that they had the habit of mind to be quantitatively literate. They also assessed the responses for the other questions in some ways that we're going to have to skip over for today. But they assessed the fourth problem to figure out whether the writer drew a conclusion and supported it. This is the rhetoric part of the argument. Was the conclusion supported by the evidence that was there? And then question 5, because it related to the graph, they assessed it in 2 different ways. Did the person check the graph against the text? So did they make a comparison between what was in the graph and what was actually in the written part of the article? And then how specific was that comparison, if so? And then the strengths and weaknesses of the graph. Like, did they think that the graph was helpful to the argument or not in some specific way? So in the study, they did this at the beginning of the semester once, and then at the end of the semester in a math class again. And I think the math class was a math class for non-majors. so this happened a while ago. Disappointingly, they found that they didn't move the needle during the semester, that students were not scoring much higher on this scale in the post-assessment at the end of the semester than they did in the pre-assessment at the beginning of the semester. So what do we know about our own students? The core assessment project that the Office of Assessment has done now twice, the first time in 2012 and then the second time in 2015, took a look at our students' term papers, and our students mean students across all disciplines, the papers that they write in their Writing in the Disciplines courses for their major, and assessed students' work using a quantitative reasoning rubric to figure out whether students were engaging with quantitative information in their Writing in the Disciplines papers, and if they were, what was the quality of that work. And so the quality of work, sort of how well, again, this is the rhetorical part of it, how well were students' quantitative arguments supported by the quantitative evidence that they used. Here's the distribution of scores that the core assessment turned up. The mean of 4.02 is the lowest among all the core skills that were assessed, although they're not necessarily directly comparable to one another. I think distributionally, we're a little bit bottom heavy on this distribution, that the majority of students are not particularly being assessed very highly on the quality of the quantitative reasoning that they're using in their term papers. And that's for those students for whom their term paper would have had an opportunity to use quantitative reasoning in it. So if they were just asked to, write a poetry piece for a creative writing class, those papers weren't included in this analysis. So these are just the papers for which there would have been an opportunity to engage with quantitative reasoning. So the quality is not particularly great. In 2012, when this assessment was first done, the mean was a little bit higher. The numbers are still pretty small, and so it's really hard to disaggregate them to get any sort of meaningful story about which students are doing better than which others. But I think, given how many students are down here at the lower end of the scale in their Writing in the Disciplines classes, these are mostly juniors and seniors that we're assessing. I think there's a lot of work to do. If we believe that this is something that we want all of our graduates to do by the time they graduate, I think we need to figure out ways of moving that needle.
Just quickly so we understand what was done.
This is what we know about our seniors, our juniors and seniors, right? What do we know about our freshmen, if anything? As students are arriving at Bridgewater, are they inclined to quantitative reasoning? Because one of the things we learned from this is that we didn't actually throw out that many papers on a percentage basis, that a majority of students, it's not a huge majority, but a majority of students actually did make some attempt at quantitative reasoning in their Writing in the Disciplines papers. So what can we say about our freshmen? Well, we have writing samples that all freshmen arriving at Bridgewater submit in the form of their writing placement exam writings, right? This they do during freshman orientation to determine what English course they should place into in their first year. And for the past few years, the English department has begun including some quantitative information as part of the prompts for the writing placement exam. So the thought was, and the wonderful CARS summer grant gave me a summer grant to look at this a couple of summers ago. The thought was, why don't we look at the writing placement exam samples and see if we can divine some of this quantitative inclination information out of our incoming freshmen. So what can we learn from assessing them? So I went through and I created a random sample. I stratified it out by writing placement because I wanted a good sample of students that placed into writing 2 as well as into writing 1 as well as into the target writing 1. So I wanted a wide range of student incoming skills, proportional to the rest of the student population. And then assessed each of the samples on a two-dimensional set of criteria. One dimension is, did the writer engage with numbers contextually? So did they actually take the numbers and discuss what those numbers actually sort of meant? And then second, did they engage with numbers creatively? So did they maybe make a calculation and bring in some new numbers into the recommendation? If you look at what the prompt was in 2013, the prompt gave them some information about extending the high school day by extending the high school year by a certain number of days. And the student task was to take all the information here and write a recommendation. Should the school year be extended by a certain number of days, right? Based on what all the benefits might be, what all the costs might be. And so, did they engage with numbers within a context, and did they do so creatively, bringing new numbers or new information into the mix that weren't already there by making some calculation? There were 2 scores for each paper. We took the average, actually, that should say average, of the 2 scores. And in any case where one of us said that something deserved a 0 and the other said it deserved a 2, then we got together and conferenced about it. But otherwise, if there was a difference of 1 point, we just took the average between the 2 of those. And so the questions that I asked was, first of all, were students' inclination toward quantitative reasoning predicted by anything else that we knew about them as freshmen? So high school GPA, their test scores, their declared major, any of that stuff correlate with how inclined they were toward quantitative reasoning. And the second question is, did their inclination toward QR predict anything going forward? Did the students who engaged more with quantitative reasoning have different outcomes in their first year coursework in college, for example? I haven't actually gotten to that analysis yet. This is still a work in progress, but I do have some things we can say about the first question. How do students' quantitative reasoning inclination relate to anything that we know about them as freshmen? So here's kind of a preliminary chart of the assessment results that we got. So this horizontal axis here is how much did students provide a context for the numbers that they were writing about? Was the context of the numbers kind of vague, or was it specific and concrete, or did they not really address context at all? And the vertical axis is how creatively did they engage with numbers? Did they bring in only the numbers that were just sort of taken directly off the page? Did they bring in some new numbers in their proposition that is not clear where they came from? So students had to recommend, should we extend the school year? And so a student might say, sure, let's extend it by 16 days, and then not make a connection between that number and anything else that was in the text. They might have gotten a 1. Or was there evidence that a student carried out a computation of some kind, or that there was a link between the new numbers that they brought in and the numbers that were in the text that was explicit? So this is kind of how students shook out on that. There's a wide range of different levels of engagement with quantitative reasoning. Generally, most students were kind of vague about the context, and generally they weren't particularly creative about bringing new numbers into their argument beyond the numbers that were printed on the page in the prompt. But I think tellingly, those students who did bring in the most new numbers in computation also happened to be the ones that were the best about reasoning and writing contextually. So the fact that there's kind of a trend that leads to a ceiling over here at the top is not too surprising to me. So what about the relationship between students' academic profiles? So here's sort of a little chart of where students in various declared majors fell out. So STEM students are sitting over here, humanities over here on the right, social sciences. Here's the students with declared majors in education and in business. In these figures, the center of each ellipse is the mean for that group, and the axes of the ellipses are the 95% confidence intervals on those means. And since these are all overlapping with one another, there's no pairwise empty intersection. There's no statistically significant difference here. Even if there are some sort of small trends that we see social science and humanities students being more willing to attend to context, STEM students being a little bit more creative than, for example, education students in bringing in new numbers and calculations. But we can't really say much of statistical import on this. Of course, it also bears mention that what a student thinks that their major is during freshman orientation may have no correlation with what they ultimately major in. But this is, this is kind of the first pass at can we learn anything from students' academic profiles. There was a little bit more significant, although not at the 95% level, difference between students' writing placement being English 102 versus 101 or Target 101. That the 102 students had, it seems, nearly significantly more ability to reason contextually with numbers and a little bit more of the creative engagement with numbers in there as well. But we might expect that that's just because having a better written essay that would get you into English 102 also kind of fooled the assessors into thinking this is better quantitative reasoning. These two are not orthogonal skill sets, right? So that's entirely possible. So the next question is it possible there's something else about the writing that can make the quantitative reasoning look better? Can students fleece us by being better writers? So here are some pairwise correlations between the other things that we knew about the students and their quantitative engagement and context scores. Those are these 3 columns here on the right. This quantitative engagement, this is the creative engagement column, and this is the contextual engagement column. So it turns out that the strongest pairwise correlates to their quantitative reasoning inclination on the creative side are their elementary algebra scores, as well as their writing placement scores. So those two kind of have an equal footing here. But students with higher elementary algebra placement scores seem to be more likely to carry out a calculation and get some kind of new number for their argument. Right? So these are students maybe with more mathematical confidence to them. On the other hand, how well a student attended to the quantitative reasoning in context was not related to their elementary algebra score, but it was related to their reading comprehension placement exam score, which is not a number that we do anything with at Bridgewater. We just have it as institutional data. But their reading comprehension seemed to be a predictor of whether they could reason with numbers within a context. But then notice also the other major correlates for these quantitative reasoning scores. This is a big one. The word count. How long was a student's writing placement exam response actually was a correlate to how well we judged their quantitative reasoning. Those students that wrote more tended to have more success in quantitative reasoning. So that's somehow meaningful. right? Again, maybe this is an assessment effect, or maybe the students that wrote more really did have more sort of intellectual confidence in what they were doing. And so kind of my proposition looks something like this, that the word count, so how much a student writes on this writing placement exam, seems to positively correlate with both of their inclinations to engage creatively with numbers and also to place those numbers in a rhetorical context. Maybe it's because they're reaching out for more evidence within the article compared to students that wrote about less. But there seems to be a positive correlation there. And then there's this disparate effect where the elementary algebra score seems to impact their creative engagement, and their reading comprehension seems to correlate more with their ability to handle numbers within a context. So when we think about what first-year students might need in order to be successful with quantitative literacy, we really need them to come in ready to engage with both of these skill sets. Right? Students coming in with stronger mathematical and elementary algebra preparation are going to be more ready and more confident to actually do the creative engagement that's required to carry out calculations. Whereas students also at the same time need strong reading comprehension in order to handle everything that happens within contextual reasoning that makes up QR. And then here are some references. I'm going to post a video of today's talk at this link if you'd like to grab that. These first 3 references all come from the journal Numeracy, which is the journal of the National Numeracy Network. It is an open access peer-reviewed journal, so it's great reading. It's most of what the field knows about quantitative reasoning since about 2004 or 5 can be found somewhere in the Annals of Numeracy, so do browse it. It's great reading. Also, the book at the bottom, The Current Practices in Quantitative Literacy, is about 10 years old right now. I have a copy right here that's overdue on interlibrary loan. I need to take it back. But I also have an electronic copy if you'd like to see pieces out of it. It was kind of a survey from about 10 years ago of a variety of higher education institutions and what they were doing with quantitative literacy in their curriculum, in their assessment efforts, in their faculty development, and all these different areas of the institution. What do quantitative reasoning programs look like? So I will share these slides out as well if you'd like them. And I think we may have -4